Kirchhoff's current law states that the algebraic sum of all currents entering and exiting a node must equal to 0. To explain this in more detail, it means that the current that flows into a junction must be equal to the current flow out of the junction. In an ideal environment, no current or energy brought into a circuit can be lost, whereas in an unideal environment, such as within a household, energy and current would be lost in the form of heat or resistance within each component that the current is flowing into. The formula of Kirchhoff's current law that is used to explain current in an ideal environment is I1 plus I2 plus I3 equals 0. The current is also given a direction. If you state that the current entering a junction is a positive value and the current that exits a junction is a negative value, then the total current must equal to 0. The man who developed this law was Gustav Kirchhoff, a German physicist. He contributed to the fundamental understandings of the laws of current and determining the current flow and voltage in a range of circuits. He applied the laws of conservation of charge and conservation of energy to electrical circuits, establishing the foundation of the behavior of current within a circuit. To provide an example of Kirchhoff's current law, I will use straws to represent part of an electrical circuit, imagining that water flowing through the straw is the current flowing through the system. Imagine there is a current of 12 amps or 12 milliliters of water flowing through this part of a straw. The sum of the current that flows out of the straw into I2 and I3 must equal the flow into the node in the straw at I1, as the current, or water in this case, cannot simply disappear. Using Kirchhoff's current law, you would state that the 12 amps or 12 milliliters of water flowing into the node must be positive, and the current/water flowing out must be negative. If you were to say that the current/water flowing out of this branch I3 is 7 amps, then using Kirchhoff's current law, this branch, I2, must have 5 amps of current flowing out, making it a negative. Kirchhoff's current law helps explain that you can only get out as much current as you put in. To bring back the idea of water flowing through the straws, if there is 150 milliliters of water flowing through a straw and 4 people want 50 milliliters of the water, this would not work, as there is only 150 milliliters of water available. This is the same with current. Each branch can only flow a percentage of the current that is already flowing through the system. Kirchhoff's current law can be done with a range of circuits, much more complicated than the example provided. However, if you ensure that each current flow is given a direction, either positive or negative, and the final result ends in 0, you know that you have completed KCL correctly.